Okay, ladies and gentlemen, welcome to our first flipped version of our classroom. I'll do this occasionally where I have you watch the video from home, take the notes that go along with it. That way, when we come into class the next day, we're able to seamlessly transition into going through some guided practice and just practicing the skills that we learned from this video. So the way that you should handle this is just follow the video as we go through it. I'll be talking through it and I'll be writing on the board as you see. But you should also be filling in your notes concurrently as the video is going. So you should have your blue packet with the notes out, opened up to this page, Chapter 2, Section 1. And there are some definitions that you can see, as well as some examples. So there are times when I'll just ask you to pause the video and you work out the examples first, and then play the video and you can see what the results end up being. All right? This is a little bit different than having you, or in fact, it's a lot different than having you in the classroom because I can't really engage you, obviously. I'd rather discuss these things with you, but occasionally I like to try this just to mix it up a little bit. Okay, so here we go. So you're looking at these notes here, and you see that we have actually six vocab words in this section, starting with negative number, positive number, etc. You guys have a very solid foundation of the concept of numbers and the number system. So what I'd like you to do, and this is the first part where you can kind of pause it, is I'd like you to think about how you would define negative number. What does it mean to you? What is a positive number? How would you explain this in terms that would make sense to, let's say, a younger brother or sister or an elementary student who's never really encountered these types of numbers? The third word there is integer. Now, integer may be new to you, or you may have forgotten what that is, but just do your best on that. And then, of course, we all know what opposites are, but see if you can explain these in the number sense term. Okay? So if you go along with that, I'd like you to pause it right now. Just think about it. You don't have to write anything. Just think about them. And then I'm going to reveal what the definitions are. Okay. All right. Did you pause it? Yes? No? All right. Well, regardless, here we go. So a negative number. Negative number simply is just a number that has a value less than 0. Any number that is less than 0 is considered a negative number. Positive numbers, likewise. It's just any number that has a value that is greater than 0. And I'm sure you came up with something like that with your quick informal definition. Now, integers are simply any positive or negative number. But the number has to be a whole number. So, for instance, 1, 2, 3, 4, or -1, -2, -3, -4, those are all examples of integers. But if I start incorporating decimals, fractions, mixed numbers, things like that, then they're not considered integers. 1.5 is not considered an integer. 3 1/2 is not an integer. -2 3/4 is not an integer. So it must be a whole number in order for it to be considered an integer. Now, opposites. If you were in class, I'd be really curious to hear how you defined opposites in terms of the numerical sense. But our definition of opposites simply looks like this. Numbers that are the same distance from 0 on a number line. If you think about that, if I would have asked you in class, if I said, okay, I have a number 5, what is the opposite of 5? You're going to tell me it's -5, of course. Right? Well, if you think about those two on a number line, you're going to know or notice that they are the same distance from 0. Actually, I used 4 and -4 here. You can see, regardless, it works the same for all of them. But each of these two numbers, 4, -4, are the same distance from 0. So that's why they're considered opposites. If you tried to mix it up and say, well, what about 5 and -3? Now, clearly, those are not opposites, and you guys know that. But if you just look at it strictly from the distance standpoint, -3 is 3 places away from 0 on a number line, whereas 5, of course, is 5 places away from 0 on a number line. So the distances have to be the same in order for them to be considered opposites. All right? couple more quick definitions here. Coordinate. We talk about coordinates when we're talking about graphing on a number line, which we will be talking about in this section a little bit, and more so when we get into this next term, inequalities. But a coordinate is simply the number that corresponds to the location of the point on the number line. You're familiar with graphing on the coordinate plane, your xy axis. Well, we're just strictly talking about the horizontal, the x-axis here. And you know that on the coordinate plane, when you reach the 0 point, which we call the origin, anything to the left of the origin represents negative numbers, and anything to the right of the origin represents positive numbers. And our last definition in this part, on this page, is an inequality. An inequality is a comparison of numbers or quantities. And the best way for you to identify, or the easiest way probably for you to identify what an inequality is through the use of our inequality symbols. Just sticking very basic here, you have your greater than symbol, your less than symbol. Okay? Some people will incorporate the not equal symbol in here. But for our sake, we're going to be making our comparison typically with our greater than and our less than. And of course, there are more inequalities, which we'll discuss later on in another unit. All right, so let's just jump into some examples here. Since we have a good solid foundation, I think we can comfortably move into this. So anytime we do an example, I would like you to try to do it first. So you could pause and try to answer these on your own, and then we'll go through them together. So why don't you try this examples 1, 2, 3, as well as that little closure set. Now, we're not done. I know you wish we were done yet, but we're not done. But I'd still call that a closure for this part of section 1. Okay, so pause it now and work those out. Okay, well, I'm going to start by going through these. We said we're going to use these inequality symbols up here, the inequality symbols that I wrote right there. I'm going to choose to use the first two in example 1. So when it asks me to compare -5 and -8 right here, I'm simply going to look at the number line and make my comparison. And I would say that -8 has a value that is less than -5. Conversely, I would say that -5 has a value that is greater than -8. That's what inequality statements look like. Simply just a comparison between the two. Now think about a number line. And think about what you notice as you move to the right on a number line or to the left on a number line. And you could answer this question. And if you were sitting in front of me, I would have you answer this question. But as you move to the right on a number line, what is happening to the value of the numbers? Well, hopefully you're thinking that they're getting larger. The values are getting larger, and of course they are. And as you move to the left on a number line, the values are getting smaller, right? Anything further, as you move further left, the numbers will decrease in value. So here's another inequality statement. -18 compared to -24. What you could simply ask yourself is, which number is more to the right, or which number is more to the left? It depends on how you want to look at it. I'm going to look at it more from the negative standpoint. Which number is furthest to the left? In this case, it's -24, which means that number, since it's more to the left, would have a value that is less than the -18. So my inequality statement is going to be -18 is greater than this -24. So it can be simply just a comparison based on the physical number line. If you're not sure, put a number line in front of you. Put your dots, markings, and just go from there and make your comparisons. Likewise, here on this next example, we're talking about temperatures. So we have these temperatures here, -8, 10, 2, -3, -11, 0, 1. Hopefully all these temperatures are a long ways away from where we are right now. But nonetheless, we'll experience this at some point probably. So we look at those 7 numbers and we try to figure out which one is furthest to the left. Because the question says we're going from least to greatest. And if I look at that, the one furthest to the left would be negative 11. So that would be the smallest value in this set. And as we move to the right, the next number that we would encounter in this list would be negative 8. Moving to the right, we're going to end up with negative 3. 0 comes next, and there's our crossover. Now we're working all positives. So then we have 1, we have 2, and then we finish up out here with 10. And on a number line, if you were to plot all 7 of those points, they would go in this ascending order from negative 11 all the way up to 10. Okay, good. All right, the last couple that I ask you here with these closure ones, which integer separates the negative integers from the positive integers? Well, hopefully you thought 0. 0 is unique in that it doesn't fall within either category. 0 is neither negative or positive. Okay? Second one in there. When is the opposite of a number greater than the original number? Well, I'm just going to say this and not write it. The opposite of a number is greater than the original number when the original number was a negative number. Okay, so for instance, if I picked negative 8 as my original number, the opposite of negative 8 is positive 8. And clearly we know that negative 8 is less than positive 8. So in this case, when the original number is a negative number, that's when you're going to have the value being larger. All right. Absolute value. This is our objective too. And this is probably really the only new concept you're going to experience in this section. And absolute value, as you can see, is the distance that a number is from 0 on a number line. Think about how we measure distance, how you report distance, whether it's distance from your house to the school, the distance from your first period class to your second period class, or the distance from your grandmother's house to the beach, or wherever it is. Think about the types of numbers that you get whenever you talk about distances, because that's going to be a very important part of what we understand about, or how we understand this absolute value. Now, the absolute value symbol, if I just scan down here, are the 2 vertical bars. You see this in example 1. These 2 vertical bars right here on this problem, anytime they encapsulate the number like that, that means it's asking you for the absolute value, or the distance that the number is. Well, in this case, it's saying, what is the absolute value of negative 5? Or in other words, what or how far away from 0 is negative 5 on the number line? Going back to that concept I mentioned earlier about distance. When I tell you that a number is a certain distance away from 0, that number is always represented in a positive fashion. So the absolute value of negative 5 is actually 5. So if we skip to 2, it's asking us the absolute value of 12. Same thing. If I'm looking at the distance that 12 is from 0 on a number line, it is 12 places away. It's not negative 12. Likewise, the distance for negative 5 is not negative 5 places away. When you walk to your friend's house, you don't walk negative 5 blocks to your friend's house. When you travel to your grandmother's house, you do not travel negative 30 miles, right? We don't ever report distance, or we don't typically report distances in a negative fashion. If I walk forward 10 feet and then I walk backwards 10 feet, that doesn't mean that I've walked 0 feet combined. That means that I've walked 20 feet. Just because I walk backwards doesn't mean that I didn't actually walk it. There's a great movie that goes along with this. If you've ever seen Ferris Bueller's Day Off, there's a great scene near the end about how they were trying to erase mileage from Cameron's father's car. If you've never seen the movie, it's funny. If you've seen it, then you know what I'm talking about. They were a little misled on how to get rid of the mileage here. Okay, I'm going to speed this up here. The next example, number 3, I just put this out here. This is a little bit more advanced because it's going to be a couple of steps. But we see the absolute value of negative 5. We're going to follow the order of operations, would be 5. And absolute value symbols are examples of grouping symbols, like parentheses. So you would always do those first. Absolute value of negative 10 is 10. Now, if we're This is our first experience where we're taking away more than what we have, and we'll get to this point eventually. But if you had 5 and you take away 10, you're actually going to cross back into the negatives, and you're going to end up with a value of -5. Okay? So the next set down here. Highlight this part here, even though I put a little star next to it. We treat absolute values like grouping symbols, like parentheses. So if the expression has absolute value symbols, then we're going to do those first. So in example 4, when it says to evaluate for x equals -6, as we've done before, simply replace the variable with its value, rewrite like I've done there. And now before we add, here we have addition. Before we add, we have to take care of this absolute value symbol. Again, like they're parentheses and they need attention first. The absolute value of -6 is +6. And then we're left with 12 plus 6, which ultimately simplifies to give us a value of 18. So why don't you try examples 5, 6, and 7 on your own here? I've shown you everything that you need in order to be able to do these, because the only thing else you're really going to be drawing upon is your knowledge of the order of operations, which we've gone over time and again. Okay? So go ahead and try 5, 6, 7. So you can pause it now, and then we'll go back through. Okay, so hopefully you paused it and you're ready to work now, or ready to check, rather. So I'm going to go through this rather quickly, just because you took the time and did it individually. Now this is the check portion. So on 5, I'm going to replace first step. And when I see number 5, or example 5 here, I see I have subtraction, and then I've got multiplication worked in right here. You have 2 outside of the absolute value symbol. Just like having 2 outside of parentheses, that means 2 times the absolute value of -3. But before I do that, I need to evaluate, or to find the value of absolute value of -3. That actually becomes +3. So this is going to become 2 times 3. So now I'm left with 18 minus 2 times 3, which is the same as 18 minus 6 when I follow the order of operations, which ultimately leads me to 12. Okay? 6, substituting in absolute value of 7 times absolute value of C, which is -5, minus the absolute value of B, which is -2. Well, the absolute value of 7 is still just 7 places away from 0, so that becomes 7. Absolute value of -5, 5 places away. Absolute value of -2 is just 2 places away. Order of operations states that we do multiplication before subtraction, so I'm going to do 7 times 5 to get 35 first. Take away 2, and I'm going to end up with 33. All right? And the last one. If I quickly go through this, 4 times the absolute value of 7 minus 2. And then notice here I've got parentheses, and then inside I have the absolute value symbol. So I have to pay close attention to there. My focus is going to start out here with the parentheses. But inside the parentheses, I have absolute values. So I'm going to rewrite. But in this case, I'm going to do the absolute value of -2 first and get 2 plus 8. Actually, I could take care of this +7 out here. Minus 2 times the quantity 2 plus 8, which is 10. And now I'm just going to evaluate 4 times 8, or 4 times 7 rather, is 28. Minus 2 times 10, which is 20. Which ultimately simplifies to become 8. Okay? All right. Well, I hope all that made sense. But if not, that's fine. Tomorrow we're going to spend some time working on it together. Give you a chance to practice, ask some questions, but at least you have the notes in front of you, something that we can refer back to. Okay, guys, have a good night, and I'll see you tomorrow. Bye.